Okay, so this is physical layer addressing. So physical addressing is a task. Here you call it as a link address or a MAC address. So I mentioned that there are two situations. One is the frames which are destined for the same network. You can add the sender address and the destination address. Frames intended outside the network, you will have to add the address of the router, the physical address of the router. And the physical addressing depends on the type of data link layer which you follow there. You could have Ethernet, you could have WANs, you could have FIDI, you can have fiber to home, all those different types of what is FTTH protocol, all those different types of protocols could run on the data link layer. So depending upon that, your physical address length would vary. So for the commonly used Ethernet, you have a 8-bit 6-byte address, that is 48-bit address. So which are, how do you check the address, physical address of your MAC address of your PC? You know that you have your Windows computers, you have ipconfig/alt, that will give you the MAC address. And whereas your Linux PCs, you have a command which is called as ifconfig. Ifconfig can be used. This is obsolete, they say. It works still. There is another command which is called as IP. So both these commands are available to do this task. So then there are link layers. Depending on the protocol, the data link layer will assign could have three types of address. One is called as unicast address, that is, and multicast address and broadcast address. We won't discuss this now because we'll just avoid some confusion here. Again, a lot of addressing coming in. We will take up all these things when we take up when we visit internet protocol. We'll discuss these addressing schemes, data link addressing schemes there as well. Okay, for the time now, you are aware of a MAC address. MAC address is unique usually. You can do a lot of tricks with MAC address as well. You can spoof a MAC address, you can change your MAC address, you can clone your MAC address. Different ways are available. So tools are available. So command line as well as graphical tools are available. So this is part of all this white hat business, this hacking or whatever, hacking or protecting our network, whatever you call it. Now this is the same situation. Alice and Bob, these two people are there and they are sending a frame. So this is the data link layer frame, the data, and it has N1 and N2. N1 and N2 are the network layer addresses. So Alice's computer is having a network layer address, that is IP, which is N1, and the destination of destination address is destination IP address is N8. N8 corresponds to Bob. Bob has the IP N8. So this IP is put in. This is the data for the data part for the frame. So this part is obtained from your network layer, and L1 is the link address, the MAC ID of Alice machine, and L2 is the MAC address or the physical address of the external connecting, the node which connects it to the rest another network. So this R1 has the physical address L2. So again R1 will send it through, will change the destination address as L4. L4 is the this is so R1's external node has a IP address N4, and this link address is L4. So you have this transmitting over the next link, so node to node links. So next link it travels. So you have the destination is L5 and the source as L4. The link address will change across networks, whereas you see here N1 and N8, that the final destination doesn't change. So node to node connectivity, node to node movement of this frame happens because of the data link layer. Again, from this node R2 to the Bob's network, there is another change, that is L7. L7 is the external connection here. And the destination is L8. L8 is the link address corresponding to Bob's PC. So across the network, the IP address does not change. IP address within does not change. Actually, it is encapsulated by the data link layer, and it just adds a link address. The link address will change across the network. Now, routers will examine both the IP address, and it will understand that it is destined for Bob's network, and it will forward it over. The routers will have more than one interface. Okay, n interfaces. So each of these interfaces should be having an IP address as well as a link address. So router knows that the Bob's network is in this particular direction and this path. It could have sent it through L3, L4, but it knows that Bob's network can be reached only through interface L2. How the router gets to know that? That is decided by the routing algorithms. The picture becomes clear when we take up routing algorithms. Okay, so but the process remains that the IP address allows you to transmit the data across diverse networks, and the link address allows you to node to node jumping, node to node hops. These are made possible because of the physical address or the link address. Okay, this we'll find out. You could use these commands: ifconfig on your Linux computer as well as ipconfig on a Windows computer. Understand the thing, get an output. To understand what this thing means, you could check up this link. I'll post this link in the classroom as well. What the output message means, you could see your physical address, all those things. Earlier, 3 years back, when I took this paper, I showed the running output of the all these commands, but since we are having a record of this, I don't want to display my MAC address, all those things publicly. So we'll take up the other two functions, the flow control and error control, next day.